Who can give me just one of the synonyms? Zeros, yes. Put it away, sir. Zeros is one of the synonyms for solutions. Yes, ma'am. Roots. And the last one. It is not vertex, but I like what you're thinking. X-intercepts. And this last one right here, this is your key to answering number 2. Because if I want these solutions for these graphs, where am I looking? Look at your x-intercepts. All right, so as I look at graph A, what would the solutions be there? Where are my x-intercepts? Where are my solutions on graph A? Yep. X equals 2, negative 4. X equals negative 4. So those are my 2 solutions there. I don't need to put the y parts of those ordered pairs, because what is the y part of an ordered pair for an x-intercept? Always. What is the y part of an ordered pair for an x-intercept? Always. 0. So if I'm looking at the graph and trying to find the solutions, I don't need to write it down as an ordered pair. I just need the x part, because the y part is always 0, and that is understood. Where are our solutions on graph B? 1, 2, 3, 4. Yep, x equals 4 and negative 1. So those are our 2 solutions there. What about on graph C? 1 and... Oh, you're doing D. Let's go ahead and do D, since that's the one you looked at. You said, what are they? 1 and negative 1. So x is negative 1, x is positive 1. And what is it for graph C then? Negative 3 and 0, yes. X equals negative 3. X equals 0. If you didn't understand number 1, is it as easy to come down and do this second question? Not quite sure what you're looking for. You've got to understand our synonyms. You're going to have to memorize those 4 words and know that they get used interchangeably. Roots, x-intercepts, zeros, those are all ways of saying solutions. This idea right here is our lesson for today. We're going to be finding the solutions by graphing. We've spent the last 2 days learning how to graph a function, a quadratic function. So we're going to use that today to find our solutions now. Go ahead and grab your books for me. We're going to start off on page 153. Page 153. If you weren't here, just write absent on those days. Yes. All right. So one of the methods for finding the roots, also called the zeros, the x-intercepts, the solutions, look, they used all 4 of those words here in this definition. One method for finding those roots, solutions, x-intercepts, and zeros is to graph it. Sometimes when we graph a quadratic equation, it doesn't cross nicely. I didn't give you any examples like that on the bell work, but it's not going to cross at a whole number. If that's the case, then we're going to need to estimate the solutions by finding the integers on either side of it. What are integers? Whole numbers. So if it doesn't cross nicely, we're going to look at the graph and we're going to look at what two whole numbers is it in between, and we'll use that as our estimate. We're not actually going to try to guess what the decimal is. We're just going to say, well, it's in between 1 and 2, or it's in between 5 and 6. That's what we're going to use for our estimate. So far, so good? Everybody should have a yellow calculator within arm's reach of them. We're going to do a lot of substituting in, because to graph these, we're going to have to fill in our tables. Example number 1, still on page 153. Excuse me. Here's what they want me to solve. I'm going to put a big red box around that. If I'm going to solve this by graphing, I need one side of my equation equal to 0. Does this function right here have one side that is a 0? No. So that's the first thing I have to do. I have to set this equal to 0. All right, so you might need to do this work off in a margin. 10 minus x squared equals 4x plus 14. First thing I look at here, as I'm trying to get it equal to 0, is I look for where my x squared is. And if it has a minus sign in front of it or a negative, I'm going to add it to both sides because I like my x squared to be a positive number. Where is the x squared right now? It's on the left-hand side. It's got a minus in front of it. So I'm going to add x squared to both sides. So it's going to cancel out over here. So I'm going to have 10 equals. Please think very carefully before you answer. Can I combine this x squared with either of the things that are already over there?
No.
No. Why not?
Because the x's are different. One x is squared and the other one's not.
That's exactly correct. The x's are different. One has a squared and one doesn't. The only way I can combine those together is if they're both just x or they're both x squareds. Since I can't combine them together, I'm just going to write them out as a sum. X squared plus 4x plus 14. Do I have it equal to 0 yet? What do I need to do to get it equal to 0? How can I get this equal to 0? We're going to minus from both sides. Which thing do I want to minus? 10. Let's minus 10 from both sides. All right, so now I have 0 equals x squared plus 4x, and then what would that last number be? 4 plus 4. So those are the two missing pieces over here. Those two blanks. We have 0 equals x squared plus what? Plus 4x plus 4. Then we're going to find our axis of symmetry. Axis of symmetry is x equals negative b over 2a. What are the values for a, b, and c? A is 1. That we found right here. B is 4. B is right here. Yep, and C is also 4, coming from right here. So far, so good? So we substitute in. I have the negative out in front. We put B up on top. And then I put A down on the bottom, getting multiplied to the 2. So I have Negative 4 over, what's in my denominator? 2. Can I simplify that at all? Can I reduce it?
Yeah.
To what? Negative 2. So my axis of symmetry is x equals negative 2. I'm going to put that on my graph. So here's negative 2 on the x-axis, right through the center of this parabola. That value is also going to be the x part of the vertex. And this is where those calculators come in. We need to find all of the y parts. Let's start with this one right here, because I know that's going to give me my vertex. So in your calculator, we're going to substitute in to this right here after we got it set equal to 0. What did we say we're putting in the place of the x? Negative 2. So I need you to grab your calculators. You're going to open up a set of parentheses. We're going to put negative 2 in the place of that first x. And then what are we doing to it? Squaring it. So I have negative 2 inside parentheses and then squared. Plus what? Plus 4, and then we have another x. So I'm going to do another set of parentheses with negative 2 inside that. Everywhere we see an x, we're going to replace it with negative 2. Plus 4. And then you hit enter on your calculator. You got what? Shouldn't be that big. So I have negative 2 inside parentheses squared. Everybody should be typing this into their calculators. Plus 4 times negative 2. How much? 0. We got 0. So negative 2, 0. That's right here. There's my vertex. I want you guys to fill in the remaining values for the table. So just what we did right here with the negative 2, we're going to do the same thing with these other values of x. Before you actually sub those in, though, I want to remind ourselves how we come up with those numbers. Because when you guys are doing the homework, the tables aren't set for you. Negative 2 was the x part of the vertex, right? We want to pick a couple numbers on either side of that. What comes on the number line before negative 2? Negative 3. Give me another one. Negative 4. I need a couple numbers that come after it. What comes after negative 2 on the number line? Negative 1 and 0. That's how they're coming up with these x values. We find the vertex value from our axis of symmetry. We put it right in the middle. We pick a couple before it and a couple after it. Yellow calculators, I'm going to give you guys about a minute and a half. I want you to finish filling in the table by taking these x's, plugging them in, and then hitting enter. And if you want to work with partner, compare your answers. That's a really good idea. Practice plugging it into your own calculator, but then compare your answers with a partner to see if you guys are getting the same thing. Did you get all of them? Okay. guys doing okay?
Wait, that's a negative.
Yep.
Nice work.
It's supposed to be a negative 2, right? Right here.
Yeah.
So you were getting it wrong?
You did that for the first one I got 4. It's the first one 4.
Mm-hmm.
What did you?
Then what am I doing?
Let me see. You have 2 different values in there.
Let me see.
Whatever you put in for x in the first spot, have to put the
Oh,
exact
I didn't
same thing
notice
in.
that.
So inside your parentheses, it should be the same number both times. When
I
we
thought
did
we was
it,
doing-
we did
oh.
-2 in both of them
I
because
thought
we
we
were
was
doing that
taking
one.
-2 to start, and then you put the other x.
You put, like, if you do this x, it has to go in both of those
Okay.
spots. Yep. What'd you get when you put -4 in? 4. That is right here on our graph. What'd you get when you put -3 in? 1. That is right here on my graph. If you remembered what we've talked about over the last couple days, you could have saved yourself 2 steps here. What do we know happens on the other side of the vertex? It reflects it. So whatever I get up here, it's going to be the same 2 numbers down here. Anytime we put our vertex right in the center, and we pick a couple numbers before and a couple numbers after, you have to count by the same amount, but then it should be a reflection on either side. So what are these 2?
1 and 4.
1 and 4. So right here and right here. What am I looking for on the graph if I want to find solutions? X-intercepts. How many x-intercepts does this graph have? Just 1. Where is it? -2, 0. This is my solution. So the 0 of the function is -2, which means the solution of the whole equation is -2. So far, so good? Yes, sir.
If the vertex was shifted up, would that make a difference?
Yes, it would. Good question. Did you guys hear Jaden's question? Did you guys hear Jaden's question?
No. What do you say?
He said if the vertex was shifted up, would that make a difference? Yes. Give me just 1 second, then I'll take your question. So,
No. Done.
look back at the bell work. Shh. Look back at the bell work. Where's the vertex of this one?
Not on the. It's on the y-intercept.
No, that's not the vertex. The vertex is down here.
I tweak. It's right there.
The vertex is down here, and this had how many solutions? 2. Where's the vertex on this one?
It's right there.
It's way up here, but we had these 2 solutions because that's where it was touching the x-axis at. This one is a very special case where my vertex is the only thing that's touching the x-axis. So in this case, I have only how many solutions? Only 1 solution here.
Yeah. Bro, because I was looking at the wrong thing. It was closer to the y-intercept than it was the x-intercept.
And that's enough. So this one had 1 solution. The ones on the bell work each had how many? Each had 2. I want to think about what Jaden said. What about if we shifted this up? If the vertex was not on the x-axis, if it was higher, where would it touch the x-axis at? Never. So what would that be for solutions? No solutions. Is it ever possible that I could draw a parabola and it would cross the x-axis 3 times?
No.
Why not?
Because it only has 2 ends.
It's got 2 sides to it, right?
Yeah.
So I either have 2 solutions where those 2 sides cross the x-axis,
Or 1 where the
or 1 solution where my vertex is the only thing that touches the x-axis, or it might never touch at all, and that would be a no solution situation. You guys feeling okay about this?
Yeah, I am. I don't know about that.
Okay, but what if, okay, say it's like a W on the graph. Yeah, it could be 3.
A W?
If it was a W, yes. And we will talk about that later on in the semester.
That's two different
No, she was just saying that
if we had a shape that was graphed and it was a W type shape, that could cross up to 4 times.
But
But that is not going to be parabolas.
Exactly. We talking
Because
about
parabolas, there was a good question anyway. Parabolas can only ever cross twice, but yes, different shapes, we've got different numbers there. Absolutely. Let's go ahead and flip over to page 154. Yes, I'm sorry, you did say you had a question.
So this one and the one yesterday too, the same thing. Like you can use either one to find the answer.
Yes, so when we're solving by graphing, yesterday we were still just graphing. That was from vertex form. This is from standard form. So we have 2 different forms that we can graph from. Quadratics have 3 forms altogether. We've only talked about 2 of them so far. We'll talk about the 3rd one next week. Flip to page 154 for me. We are going to use a quadratic equation to find 2 numbers that have a sum of 24 and a product of 143. So I just want to break down these words real quick. If something has a sum of 24, what operation in math is a sum? Addition. Do I know what those 2 numbers are?
No.
No. So I'm just going to let some letters stand in for that. So this is just like something plus something else equals 24. So x plus y equals 24. I don't know what x is. I don't know what y is. But if I add them together, it's 24. You guys understand that so far? All right. What does product mean?
Ain't that division?
It's not division, but you're close. Multiplication. Product means multiplication. If I multiply those same 2 numbers together, so again, I'm just using x and y, x times y is supposed to come out to be 143. Again, I don't know what those numbers are, that's why I've got letters in there. I'm going to look at this one right here. X plus y equals 24. We're going to do a little bit of algebra magic. If I subtract x from both sides, what would I get?
Y equals 23.
Nope.
I mean, 24.
24
No.
minus x. Yes. Y equals 24 minus x. Do you guys remember in the last module when we used some substitution? What does substitution mean again? Replace. I said earlier that x plus y equals 24. Just 2 numbers added together. Again, I don't know what those 2 numbers are. I'm going to take all of this right here, and I'm going to let it take the place of the y here. So x plus 24 minus x equals 24. What happens if I do x minus x? Cancels out, so that'd be 24 equals 24, right? So we have something that's true. I'm going to let this be one of my unknown things. This is going to represent one of my numbers. And this is going to represent the other number. So x represents one of my numbers. And what are we going to let represent the other number here? Nope. We just wrote this down.
Oh, Y.
What did I let y be equal to, though? 24 minus x. 24 minus x will represent the other. What does product mean again? Multiplication. So if this is one number, x, and the other number is 24 minus x, when I multiply these 2 mystery numbers together, it's supposed to come out to what? 143.
What?
Oh, we got substitute.
Yep, we're substituting. I want the product, when I multiply these things together, to come out to be 143. So here's the x, and here's our substitution, right there. So far, so good? Whatever I want it to add up to, it's going to be x, and then that number minus x. If I'm trying to find these two numbers, let x be one of them, and then the sum minus x for my other number. What can I do with this x that's out in front of the parentheses? I can distribute that. So I get 24x, and what do I get when I do x times negative x? Negative x squared. Is this equal to 0? Is this equation equal to 0?
No.
No. We're going to set it equal to 0. So I need to subtract 24x from both sides. That'll make that one cancel. But if you do it to one side, you got to do it to the other. How will I make this one cancel? I want to make it cancel out. I don't want it on this side anymore. I want to get a 0 over here.
Add a positive
Yes.
x squared.
Add x squared to both sides. Now will I get a 0 over there?
Yeah.
Yes. Positive x squared, so that's up at the front. Negative 24x, so minus 24x. 143. Was that 143 a positive or a negative? Positive, so I put plus 143. I want to pause right here before we go on. Do you guys understand how we got this quadratic equation here?
Yeah.
Starting from right here. I'll go back a little further in a minute, but starting from right here, do you understand how we multiplied? And then I wanted to make one of the sides of my equal sign a 0. We could have subtracted 143 from both sides. That would have given me a 0 also. Your book decided that we were going to do this. I don't know why they made that choice.
I feel like that's easier.
They added x squared to both sides to make it cancel from here. We still had this over here, and I wanted to make it a 0, so I had to minus this then, so that I made them both cancel, and I can get a 0 over here. Does that make more sense? Okay.
I just, Ms. Bo,
Yes,
I don't
sir.
get how we got the bottom. Like I get the whole all the steps, but I don't get how the 0. Oh, so the 0 is that whole side right there?
Yeah, because this canceled, so that was a 0, and then this canceled,
All right.
so that was a 0. What happens if I add 0 and 0?
You get 0.
I get 0. Everything over here canceled.
Why is the 0 on that side?
It doesn't matter which side.
All right.
You get to decide whichever side you want it to be on. The book chose this side. I don't know why they picked that side. I would have gone with the other side personally, because I think the other side would have been less work.
Yeah.
So I want to take this equation right here, x squared minus 24x plus 143. Let's identify our A, B, and C so that we can find our axis of symmetry. What is A? A is 1. What is B? Negative 24 is B. What's C? 143. So how do I find the axis of symmetry now? Yes, x equals negative b over 2a. All right, so I'm going to rewrite our equation here. We had 0 equals x squared minus 24x plus 143. I need head up for me, sir. We identified our A, our B, and our C from this. We said that A was 1, B was negative 24, C was 143. So then we plug into this. So we put the negative 24 up on top, and we put our A value right down here. What happens, though, because I had two negatives here? Turns into a positive. So this is positive 24 over 2. Can I simplify that at all?
Yeah.
X equals what?
12.
X equals 12. There's my axis of symmetry. Your book is actually letting us graph something. We're going to do this. Go to 12 on the x-axis. We're going to put in our axis of symmetry here. That's going to cut that parabola in half. X equals 12. That goes right in the center of my table here. We want a couple numbers before 12 and a couple numbers after 12. What's a couple numbers that come before 12 on the number line? 11 and 10. Did they put those on the table?
Yeah.
Yeah, they did them at the bottom instead of at the top, but they still got them on there. I want a couple numbers that come after 12. What comes after 12? 13, 14. Do they have those on the table? Yes. We're going to fill in this table. Where's the equation that I need to be using?
At the top.
This guy right here. Let's plug our vertex in first. What's the x part of our vertex? 12. So I put that in the place of the x, and then what do we do to that? Square it. And then what? Minus 24, and then we plug a 12 in again. And then what? Plus 143. You got negative 1? Okay. I can go ahead and plot that. That's right here on my graph. Take about a minute and a half. I want you guys to finish filling in this table. So take the other x's, plug them in. I'll ask you for what those are in just a minute. Yeah, if you've got those points, go ahead and plot them. Absolutely. What'd you guys get when you plugged 14 in? 3. So 14, 3, that would be right here.
Wait, on number 13, I got 168.
Ooh, check again.
What?
Plug it in again.
Did I not do it right?
You didn't put 13 in. You put negative 1 in.
Oh. I tweaked so bad.
When you put 13 in the place of x, what do we get? 0. So 13, 0. It's going to be right here. Did you have to plug in the other two?
No.
Why not?
Because it's reflection.
It's going to be a reflection. So down here, when you plug 11 in, what should you get? You should get a 0. When you plug 10 in, you should get a 3. Do I have enough points to draw my U shape in here?
Yes.
Yep. Where are my solutions? Where are the solutions here? 11 and 13. Right here are my solutions. X equals 11. X equals 13. How can you use the table to help you figure that out? Zeros. Looking at that table there, if you look down the Y column, there's a 0, so this is a solution. Here's a 0, so this is a solution. Zeros of the function are 13 and 11. We said at the beginning we were looking for two numbers that added to what? 24. If I do 13 plus 11, what does it add up to?
24.
24. Cool.
Multiplies for 143.
Grab your calculators. I want you to double check that. If I do 13 times 11, 143. So the two numbers we were looking for were 13 and 11. I'm okay with both being true. Let's go and look at one more example to wrap up today. So we're going to go over and look at page 155. So far, everything's landed really nicely on a whole number, right? Solutions aren't always nice and pretty. I want you to look at this graph. Where are the x-intercepts on this graph? Where are the x-intercepts on the graph on page 155? Are those whole numbers?
Oh, they're negative. They're decimals.
They're decimals. They're going to be somewhere in here.
So that's like negative 1.9.
Well, I don't know. And somewhere in here. Let's talk about what we're going to do with our table so that you could graph it yourself. And then we'll talk about how to estimate those zeros. Yep, that's okay though. Look up here. Here's the function rule. Do we have to get this set equal to 0 first?
No, it's already set.
Already set equal to 0. Thank goodness.
It's like 5 steps.
Thank goodness. We need some saving of steps right now. Okay, so it's already set equal to 0 for us. So I want my axis of symmetry. How do we find the axis of symmetry again? Negative b over 2a. What is the value for a? Close. Negative 1. Here's my a value. What is our value for b? 3. And our value for c? 7. So we put 3 up in the numerator. I have negative 1 down here. So this is negative 3 over what? Negative 2. What happens when I divide two negatives? Makes it a positive. So x equals x equals positive 3 over 2 is my axis of symmetry. Is that a whole number?
No.
No. What is it as a decimal?
It's like
1.5. Did they put 1.5 on this table?
Yeah. I mean, it looked like, yeah, it's basically 1.5.
On the table.
Oh, no.
1.5 is in between what two whole numbers? 1 and 2. So the vertex is going to be here, in between the 1 and the 2.
That means we gotta make a separate box.
Nope. Did they pick a couple numbers on either side of that vertex?
Yeah.
If I think about a number line, 3 over 2, that's the same as 1.5. Give me a couple whole numbers that are smaller than 1.5. 1, 0,
Negative 1.
-1,
Negative
-2. Did they put those on the table?
Yeah.
Yeah, so we've got whole numbers that are smaller. Do we have some whole numbers that are bigger?
Yeah.
Give me some whole numbers that are bigger. 2, 3, 4, 5. Why do you think they picked out whole numbers for us to use? What are we going to do with these numbers? We're going to go plug them in, right?
Oh, yeah.
If I'm plugging them into my calculator, wouldn't it be so much nicer if they were whole numbers? Yeah. As long as I pick things on either side of my vertex, I should be okay. So I want you guys to do that. We're going to plug in up here. So negative, what's the first thing they want me to plug in for x? Negative 2. So negative 2 squared plus what? Plus 3, and then I have to put negative 2 inside my parentheses again, plus what? Plus 7. I want you guys to do this for all of these x's. Finish filling in the table, work with a partner if you want to. I'm going to give us about 2.5 minutes to fill this in.
Is it negative 3 on purpose? Right there at the bottom where that you wrote.
Those?
Yeah, no, right there, like the one in front.
That?
No, it's a negative, like the very
That?
first, yeah.
Yes, because that was negative.
Oh, okay. I didn't
Yep.
see that.
I wrote that negative down at the beginning, and then we had the x. Good question.
So that's a negative, not a subtraction sign.
Correct. That is a negative on the calculator. Don't forget this guy right here. That came from right here.
Already?
So yeah, you should have a negative right at the very beginning, and then you're going to substitute in your x and square it. Get them all filled in? Get them all filled in for me, and then you can do that. Get them all filled in? We're doing this right now. What'd you get when you guys subbed in negative 2? Negative 3. So there's a point at negative 2, negative 3. That's right down here. What'd you get when you plugged negative 1 in?
3.
Positive 3. Interesting. It's all the way up here. What'd you get when you subbed 0 in? 7. It's right here. What about when you subbed 1 in? 9. That's up here. On the other side of that, what did you see happen? Because our vertex fell right in between these two.
It's 2, 9,
2, 9. 3, 7. Do you guys see that reflection happening again? We got 9, 7, and then 3, and finally negative 3. What have we been looking for on the table? Which column do we look at? I get my answers from X, but first I look where?
Y.
I look at Y, and what number do I want to see?
Whole number.
No, what am I looking for if I'm trying to find the solutions? Let me come back here. What did we look for?
0.
0. The Y value is 0, and then I grab the X as my answer. So I'm looking down the Y column, and I'm looking for
0.
So we don't have
Is there a zero? I mean, I don't see 0 on my table, but is it ever crossing the x-axis?
Yes.
Yeah. I want you to look very carefully on the table. Look at these first two right here. The first two numbers, -3, and then it switches to being a positive, right? What's in between -3 and +3?
0.
0 is somewhere in between there, right? So that means that my solution has to be in between these two numbers.
Oh.
It might be 1.5, it might be 1.2 or 1.7. I don't know. I just know it's somewhere in between those two. So we're just going to say that it's in between -2 and -1. I don't know exactly where in between. I just know somewhere in there. Because somewhere in here it had to cross the x-axis. It had to hit 0. Do you guys see anywhere else like that on the table?
Yes, in between 4 and 5.
In between 4 and 5, yes. Right down here. Because in between 3 and -3, it had to hit 0. In between 4 and 5. Does that match what we see on the graph?
Yes.
Yeah, in between these two whole numbers. Again, I don't know whether it's 4.5 or 4.629. I don't know. But I do know the whole numbers that it's in between. That's as much as we're going to do as far as estimating when it's not a nice, pretty number on the graph. You can tell me what two whole numbers it's in between there. That is all we are doing in your book for today. Homework. This one's all in your book / computer. You'll turn it in on McGraw-Hill. Some people have been having difficulties getting the integration with Canvas to work. If you can't access the homework through Canvas and you're trying to get to it that way, please let me know, because the district is trying to collect information as far as who's having difficulties. Because they're trying to fix it, but I need to know who's having problems with it. If you're having problems getting there through Canvas, you can still go to Clever, go to McGraw-Hill, just like we've been doing before, so you can finish up that homework. Guys, the homework is solving by graphing. That's why I passed graph paper out to everybody at the beginning of class. So you can graph it, make your tables, find your x-intercepts there. Problems are 1 through 3, 4 through 10 even, 13 through 15, and 57. All right? That one is due on Monday. The homework that was on paper, the back side of that packet, I'm going to check that on Monday. All right? I didn't have enough time in 4th period, and I'm going to be fair to all my classes, so you guys get the extra day just like they do. All right? You're welcome.